In this video, I'm going to explain the idea of functions in computer science and programming. But before we do that, you should know what a function is in mathematics, right? So in mathematics, a function is defined as mapping from set A to B. A to B, let's say it's a function F is defined as mapping from set A to B. For example, let's say if set A has elements 1, 2 and 3. Set B has elements, let's say A, B and C. It doesn't even matter what A, B and C. It can be anything possible, right? And if you say map 1 to A, 1 to 2 to B and 3 to C, it's a function. And the idea is that every time you give 1 as an input to the function, you will get A as the output. Right? And if you give 2 as input to F, you will get B as output. Right? Similarly, and for 3, let's look at some interesting functions. And n is used to denote the set of all natural numbers. Natural numbers means it does a set from 1, 2, 3, 4, all the numbers that you can think of. Okay. And we can define a simple function, let's say g, and what it does is it takes x to x square. These are just fancy mathematical notations. It will be clear from the context what do I mean by it, right? So if I say g of 1, you will get 1, right? And g of 3, you will get 9 because 9 is the square of 3, and similarly other numbers. Okay. So you might ask, why I should learn about functions, right? After all, I'm going to work with computers, and why should I worry about mathematics? Okay, let me explain you a scenario. Let's say you are creating a game similar to PUBG, right? I believe most of you are familiar with this game. It's just a shooting game, right? You shoot your friends and friends shoot you and so on and so on. Okay, let's say Bob, your customer. Okay, you have built the game, so your customer is Bob, and he's buying your game, right? So and he while playing the game, he presses the shoot button, and it shoots as expected, right? So Bob shoots. The avatar shoots. Okay, and Bob is quite happy, right? So after 10 seconds, Bob shoots again. Right? But now the avatar jumps. Now it jumps. So Bob is so angry right now. Okay, he doesn't like your game because your game, one time the shoot button is working, the other time shoot button is not working, right? And he's angry. He gives negative reviews and everything, and no one buys your game anymore. Okay, so these kind of things happen often in software engineering, and the software we produce, because computers are not humans, right? So they don't understand mathematics. They don't know what mathematics is. They don't know what functions is. And it is up to the programmer who is developing the software to ensure that the program works correctly. So function is nothing but an add-on to what a computer can do. It's just simply an abstraction. Okay, and knowing that and writing your programs in a good way will make sure that your program works correctly most of the time, right? So let's take a look at how computers are in general. Okay. So this is the memory model, right? It's not exactly memory model. It's just how the computer was envisioned by von Neumann. Von Neumann is a great mathematician and a computer scientist. Okay, so he with another notable name, let's say Alan Turing. He's Alan Turing. Okay, these two are the magnificent figures who laid the foundation for the early development of computers. So according to von Neumann model, a computer has, let's say, three important parts. Right? You may see many parts, but it's actually three major parts. One is that memory. Okay, memory is something similar to your RAM and cache, right? And the second one is, let's say, CPU. CPU is comprised of a control unit and arithmetic logic unit, right? What a control unit does is control unit controls which code runs at any given instant of time. It controls which code runs, what are the instructions are being run. Arithmetic units are used to do additions. Okay, they just do bitwise binary additions. It might sound a little bit complicated, but what it does is that it just adds two numbers. Okay, that's it. And the third unit is input and output. You can consider input and output as both combined as a single abstraction. Okay, mostly people will call it I/O, right? So input the examples are your keyboard, your joystick, or your mouse, whatever. Output may be your screen, or it may be a file, right? Can be a video file or audio file or anything. You can output. Okay. So nothing else. Computer knows just these things. Okay. So the programmers are faced with a task, a mighty task, right? So computers can only understand zeros and ones. They cannot understand anything else. But humans can't work efficiently with zeros and ones. We are used to work with decimals and English, basically human readable language, basically, right? So they develop programs or softwares. You can think of them as softwares, right? They are called interpreters and compilers. So what they do is, you can still write in a high level. I will show you an example code in C. This is an example code in C programming language. Okay. So I have defined the function add1. What this function does, it simply adds 1 to an integer and returns a value. So add 1 of 10 will be 11, add 1 of 2 will be 3. Okay. As you can see, we are not actually writing in terms of zeros and 1. We are using human readable letters, right, and words to build your program. Still, it might, if you are new to programming, this still might look a little bit complicated and weird. Okay, so what is this %d, and what is this printf, and what are these curly braces, and what are these semicolons? You might ask all those questions, right? So, but still you can understand, the general idea is that it's still readable. It's much more. You can think of semicolons as the end of the line, like dot, right? And you can think of curly braces as some block of code. So main represent one block of code. This function add1 represent one block of code, and int is nothing but a return value. Okay. So the examples we have seen here, right? For examples of function. So G, it takes natural number as its input, and it returns a natural number as its output. Okay, so here this function, it takes an element, the elements from set A as input, and returns the elements in set B as input. You can think of B as some other type. Okay. So this is the basic idea, right? But the point is that still the functions we have are not the same as the functions that we see in mathematics. Okay. It just the function add1, right? So in C, this is how you define a function. You first define its return value. Okay, its return value, which is int. Then the function name. Then the type of its input arguments. Right? Here we only take one input. Okay, and you can simply do printf some weird thing. Okay, whatever weird thing you can think of, you can actually do it here. Okay, and still the code will compile and it will execute, right? But as you can see, it just printing like we are adding 1 to 10 and the result is 11. But some weird stuff also happens here. Okay, you can do anything. So it is still not the same as mathematical function, but we are getting closer, right? We are getting closer. So almost any programming language you might have heard of, all the famous programming languages, they define functions with these type of functions are called impure functions. Pure functions are the functions which behave exactly like the mathematical function. Like not exactly. Most of the time it behaves like a mathematical function, and impure functions are described here. Okay, I just showed you an example. In the programming languages like Python, C++, Java, JavaScript, or C# or anything, they work the same way. Okay, so that's it.